Sysdig, and yeah, the goal of this session is mainly the hands-on. We'll have a couple of exercises to do, and I'll help you to do them. But first, if you have any questions, I'll be happy to answer. Okay.
Once again, we have the mics if there are any questions. Also, during this hands-on lab, we've got a number of Sysdig folks all around. If you need help at any point, just raise your hand and someone will come over and help you one-to-one.
Okay. First of all, you need to install the Sysdig. For sure, I hope you have done already. And download the captures we made for these exercises that are available on this address. The first exercise is on the trace file numbered 1. And in these trace files, you will find some weird activity on the machine because someone is trying to log into. Your goal is to find what he is doing and maybe find his IP address. So I give you 10 minutes, something like that, and to get into this. And after we will walk to this a possible solution. Cool. Mm-hmm.
If you get stumped at any point, don't hesitate to raise your hand. Someone will come over, give you a clue in the right direction.
Hey, few minutes left for this exercise. So, if you are stuck from something, just raise the hand or yeah. Okay. Ah, okay. 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 Okay, so who was able to find out the IP address of the attacker? Oh, cool. So just let's see how we can troubleshoot this. We said that some network activity it was there to someone trying to log. So let's first of all expect the network activity using the top cons chisel, which reports all the connections, all the top connections. But yeah, there is a lot of HTTP traffic there. Let's just focus on the SSH port, so the 22 ports. And here we can see a lot of traffic from this host, 10.1.1.123. Which is kind of weird because if you need SSH, you just run a single connection, not too many of them. So there's something weird here, and how we can inspect the traffic here. It's not so feasible because SSH is encrypted. So let's see if meanwhile SSH printed some logs about what it was doing. So we have another chisel which is spy syslog, which, as the name says, just prints everything that is logged on syslog, and let's also filter by SSHD. And here we can see all the logs, and there is some invalid user activity. Many different users' name tried by this host. So it looks very likely that he's trying to do a dictionary attack. And yeah, so this is the culprit. Here. Yes, it's this one. Are you able to see it, or I can show in the slides? So mainly here we use the top cons chisel and the spy syslog chisel. Any questions about this? Okay, so let's go to the next one. Here there is another trace file, 02, and here there is a filing HTTP request, and the goal is to find the filing request, but bonus point if you're able also to understand why it's failing, so what's wrong in this failing request. So go on the 02 file and do this. For sure, you can leverage something that I already showed you. So we talked a lot about HTTP. So yeah, you can leverage that.
Once again, if you need any assistance, just raise your hand. Someone from Sysdig will be around to help you.
As a hint, I suggest you to leverage the HTTP log for sure that I showed you. You can. There are plenty of requests, but yeah, with some grep you can find the wrong one, and then it's better to get into the single request and see, yeah, what's happening. If you are in Sysdig, then it's more, yeah, you should try to see the connections on, yeah, and on the HTTP ports and see what they have inside. So, have somebody managed to find what's going on? Yes? What was the culprit? What? WordPress? No, it's more something related to the configurations of the software, not like application level, like WordPress. It's more, yeah, that's it. Yeah.
All right, Starbucks gift card for you. Well done. Well, can you repeat it?
Yeah, the issue is that the host header was wrong in one of these requests, and let's see how we can troubleshoot this. So, as I mentioned, it's a good point to troubleshoot the HTTP to use the HTTP log because you have all the log of the request happening. So you can easily grep by code equal 5. And you can see there are two requests filing. And once we have this request, we can inspect the traffic inside and see why they are wrong. So with Sysdig, let's open it. Okay, so let's go to the containers view. Our entry point for HTTP is the Nginx proxy. Inside this container, as I mentioned, we can change view and keeping the same context. So if now we go to the connections view, we see just the connections happening inside this container. There are many of them. Many are with these 172 addresses, which are internal of our environment. But the request wrong was from, there was mentioned another IP. Let's go down if we find it. At the end we can see there are these requests coming from the outside. Let's go with echo inside them to understand what's going on. So with F5 we can see the exact request and response. So this one is working well. We can see 3002 response code, which is fine. And instead, let's go with the other of these hosts, the .17. Here, we can see that, this is the error request. If we see the diff between these and the previous one, we can see that the host entry is different. Here, it's using the IP address of the server. Instead, in the previous one, it's using WordPress. So there is the client using the right virtual host to in the request, and Nginx is not configured to answer in the using the IP address of the host as a virtual host in the HTTP request. So the host header was wrong, so we should tell our client to change it. So this is the HTTP troubleshooting here, which you can see, Sysdig is pretty useful to troubleshoot this stuff. Also, we did this offline, and it can happen, for example, as I mentioned, if you receive this an alert, you can see the request going on and troubleshoot them. As an exercise, this is more it's not. It's a aware behavior happening in the system, and I'll tell you after some explanation about this. But First, let's see if you can figure it out why there is a script run that generated a weird syscall behavior. And I'll suggest you to go as a hint to the Sysdig errors view. And the first point is understanding what this behavior is about. And yeah, if you're also able to figure it out why this process is doing this stuff, yeah, go ahead.
Assistance. Sysdig folks will be here to help. This is your last chance this morning to get one of those caffeine cards from Starbucks, so use the help.
Okay, so have you been able to find out something about what's happening in this trace file? Nobody? Yeah, go ahead. Yeah, there are tons of close events, and let's go on this and see what's happening. So if we run the top system calls chisel, we see something weird. We have some syscalls that have like thousands of them, and close instead there are 1 million close events, which is very weird, right? As I mentioned earlier, if you go with Sysdig on this, with Sysdig, all these errors are EBADF, which on the closed system calls means that the file descriptor is not is bad. It's not correct. So the process doesn't have the file descriptor open. With Sysdig, you can go with dig and see which process is generating this. And in this case, we can see that is a Python script generating all these events. Let's go deeper and see this these close events. So let's add as a filter proc name equal Python and event.type equal close. Seeing a bunch of events, we can see that there is Python is calling close with a file descriptor number constantly increasing. So it looks like it's trying to close all the possible file descriptor number. So it's kind of weird, right? How is possible is doing this? A curious thing, if you were able to figure out, is that this is a script, right? So maybe we are lucky enough to see the content of this script, because Python, to run it, needs to read it somewhere, right? So if we put procname.python and for descriptor.name equals contains script.py and use the echo file descriptors echo on echo chisel. We can see here actually the content of the script. So here we can find that this script is calling is creating a sub process, and this function accepts a parameter called close FDS, and it's called true. And with this parameter, this Python library tries to close all the possible file descriptors. Why is doing this? When you have a process that does exec, so runs another executable, the file descriptor opened are kept opened. So if the process is not aware of this, just starts to open other files, do other stuff, and the file descriptors are kept open. So it's a leak of file descriptors and a leak of resources. So as a safe thing, some libraries like this one, but also I found the same behavior, or for example in Keep Alive D, they, as a safe measure, they close all the possible file descriptors, which it was working kind of well a couple of years ago when the max file descriptor number was, the default one was 1,000 and something. So 1,000 events are not so much. But recently, in the latest kernel, the default amount is like 500,000. So there are tons of system call generated just to do this, which is very weird. And a best solution to do this is simply adding a flag when you open a file called cloexec, which means that the kernel automatically closes that file descriptor when exec is called. And it's way more efficient because it happens automatically done by the kernel. So yeah, this is the culprit here, which is a nasty troubleshooting behavior that I found out a couple of months ago, troubleshooting our stuff. And yeah, it was nice to share with you. Yeah. Thanks everybody to joining this hands-on today. I hope you liked it. And yeah, that's it.
Thanks so much, Luca. Luca will be around here in the session and in the break area in case you have more questions for him. I think we've got one question right now, which we probably have a moment for. Hold on one second.
Just real quick, could you show us, again, maybe so we could capture it on our phones, how you went and printed the script?
What? Sorry?
How you captured the script being loaded and printed that out?
Yeah, exactly. I started the capture. When I made this capture, I started the capture, then ran the script. So in the loading of Python, it obviously reads the script to execute it. So for this reason, it's available there. Yeah. Yes, I have it also here. It's in a more big font. So I use the echo FDS chisel and proc name we equal Python as a filter, and fd.name contains script.py. Script.py is the name of the script. In this way, all the Python activities filter just to match this file descriptor. And with echo FDS, it's printed on the screen. So, yeah.
Thanks again, Luca.